when it comes to the digital computer, it always going to deal with the zeros and ones. That is what binary numbers or a machine code. This non-positional Roman number system is the example, and we are going to use certain symbols in order to express or to represent the numbers. The number system which is having a total number of digits which is present in a particular number of system, then we are calling that as what? Base or radix. Positional number system, in that we have a decimal. Totally it is of 10 digits from 0 to 9, and it will express with the power of 10. Hello everybody, a warm welcome to one and all. Welcome back to the session 4 of Unit 1 in B.Ca.'s first semester subject called Fundamentals of Computers. I am Rohini, TS Department of Computer Science, Vidhyaashram, first grade college, the Temple of Excellence, MYSURU. So before getting into our today's session, we'll just have a quick recap of our previous session. As we know, in the last session of this unit, we had a discussion regarding what are the classification of computer we have. Under that, we have a different categories. So based on the principle of operation, based on the size, and based on the performance, capabilities, and also we have a number of users, number of microprocessor. Based on that, we have a different category. Amongst that, we are going to mainly concentrate on the principle of operation and then configuration. So in this principle of operation, we have an analog computer, digital computer, and also we have a hybrid computer, right? So when it comes to the configuration or size and performance, based on this, we have a mini computer, we have a micro computer, and also we have a mainframe computer along with a supercomputer. These are the different types of computer which is based on the configuration. This is what we had a discussion in the last class. So in our today's session, we're going to learn about the new concept that's all regarding number system. So first we'll see the introduction of this number system, and also I will be discussing what are the different types of number system we have in it. Let me get into the session. Before that, you need to recall the concepts which is related to the digital computer. So in the digital computer, we are going to give more weightage for the counting purpose rather than measuring, right? So when it comes to the digital computer, it always going to deal with the zeros and ones. That is what binary numbers or a machine code. If you consider the ancient days, how the people were counting. So nowadays we have a computers, we have a digital computer with a digits or with a certain symbols. We can calculate or we can get to know the value of any of the number. But if you consider the ancient days, people were using stones and they were using pebbles and some sticks in order to do the calculation. So at that time, this number system come into existence. That means what? We have to give a weightage for a particular number. We have to give a value for a particular number. Instead of representing it in the terms of the stones or pebbles or any of the stone, we must have some systematic way of representing the numbers. That is what the reason of evolution of this number system here. So you can see here in the digital computer, data and instructions are stored in the computer's memory using binary code, and we are calling this code as a machine code itself, and it consists of two numbers, that is what 1 and 0, and we are calling it as a bits. So this bit can be either 1 and 0, and also in this number system it will going to use us a well-defined symbols, that is called digits here. So we are using certain symbol in order to represent the number. Then we are calling that representation of a numbers using symbols are called as what? Digits. Then what about number system? What is its definition? You can see here, a number system is defined as a system of writing to express the number. We are expressing the number with certain system. Then we are calling it as a number system. Along with that, it is a mathematical notation for representing the numbers of a given set by using digits or any other symbols. By making use of a symbol or digit, we are representing the number. Then we are calling that mathematical notation as a number system. Very, very important question. What is number system? Okay, then what are the different types of number system we have? It consists of two types. One is non-positional number system, other one is positional number system. We'll see each type one by one. We'll see about the non-positional number system here. It consists of different symbols that are used to represent the number. Here also one of the methodology to represent the numbers. Then how we are representing it? With the help of symbols. Then what is the example for this non-positional number system? That's of Roman number system. So if you just go back to your school days and if you could remember the Roman number system. So how we are going to represent the 1? That is with the help of I. That is also one of the symbol. How we are going to represent 5? That is with V. And if I wanted to represent 10, that is of X. Fine. So here you can see I is equal to 1, V is equal to 5, X is equal to 10 and L is equal to 50. So this is somehow convenient up to 1000. What if it is beyond that? What if I wanted to write the lakh, or if I wanted to do some calculation or arithmetic expression with these symbols? Somehow it is not so convenient. That is what the reason of having a positional number system. So in this non-positional Roman number system is the example, and we are going to use certain symbols in order to express or to represent the numbers. And then this number system cannot be used effectively to perform an arithmetic operation, as I said earlier. So this is somehow convenient up to 1000 numbers. So if you wanted to perform any of the arithmetical operations and all, somehow it is not so convenient or effective. That is what we have a second type. That's all regarding positional number system. So here we are representing the numbers in the terms of digits. When we are representing the numbers in the terms of symbols, that is non-positional. If we are representing the number in the terms of digit, then that is positional number system. In the positional number system, again it is of 4 types. That includes decimal number system, binary number system, octal number system, and we have a hexadecimal number system. So before understanding all these 4 types, first you need to understand certain basic terminologies of this positional number system. We'll see that here the total number of digits present in any number system. So here any represent what? It can be decimal number system, octal number system, or hexadecimal or binary. This can be any number system. So the number system which is having a total number of digit which is present in a particular number of system, then we are calling that as what? Base or radix. The total number of digits present in any of the type of number system, then we are calling that as a base or radix. For example, if you consider the number system, decimal number system, that is of 10 digits, then that base is what? 10. If I consider octal, that is of 8 digits. So its base or radix is 8. In that way you are going to learn. Okay. We'll see the next point here. Every number is represented by a base or radix. Then we are calling that radix as what? X. And then which is represent x digits. So if I wanted to represent any of a number with a particular number system, then we have to mention its base. So in order to mention the base, we are calling that as x. That x can be the total number of digits which is present in a particular number system. If I consider a binary, its radix is 2. If I consider octal, radix is 8. If I consider hexadecimal, 16. If I consider decimal, then its base is 10. Okay, so the base will going to be written after the number as a subscript. How we are going to write a radix or a base? That too as a subscript, such as you can see the example here. Here I have a number. The number is 360, and now I wanted to write its base or radix. That will going to be written within the parenthesis or a pair of parentheses as a subscript. If I am writing like this 10 is a base or a radix for the given number. So if the base is 10, then I can say that this is a decimal number system. So here if I am writing it as 2, then what it means? Then this is a binary number system because its base is 2. You are going to get to know of every type of positional number system one by one. Okay. Then how we are going to represent any of the number, its base and radix. So here we are going to have an integer. Within that, as a subscript, you are going to write the base or a radix. Okay. So first we'll see about the decimal number system now. So, as I said earlier, you need to concentrate on the 3 things here. What is the type of number system, whether it is decimal, octal, hexadecimal or binary. Okay. So, find out the type of number system. After this, you need to concentrate on its base or radix value. Okay. Then concentrate on the total number of digits present in it, total number of digits which is present in that particular number system, and it is represented with a power of what? power of what number? So these are the 4 points you need to remember for all the types of 4 positional number system, whether it is a decimal, binary, octal or hexadecimal. You need to concentrate on these 4 points along with one or more example, and then its representation. This is what you are supposed to learn from each type of positional number system. Okay, first we'll go with a type. What is the type of this number system? That is positional. In that we have a decimal number system, and you can see here it's most commonly used or most widely used type of number system. And in this, the decimal number system consists of 10 digits. What is the total number of digits here? That is of 10. It has a total 10 digits. Then it will be from 0 to 9. We are starting with 0. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. That is what comprises of total 10 digits, and we are considering from 0 to 9 as a decimal number. So that totally it has a 10 digits. How many digits we have? That is 10 digits. That's why its base or radix is 10. What is its base or radix? That is 10. So why? Because base or radix represents the total number of digits which is present in a particular number system. In this decimal, we have a total 10 digits. That's why its base or radix is 10. Fine. These digits can be expressed used to represent any numeric value, and this will going to be represented in the power of 10. This is represented in the power of 10. Here you can see the example here. So what is that? 140. The base is 10. 140. The base or radix is 10. So that here 140, which should not be beyond the 9. That means here I should not consider this as a 14. I should consider this as 140. Okay. Or else I should not consider this as what? 1 separately and 40 separately. That will not be the case. 140. These are all the 3 independent numbers, and its base is 10. Fine. Then we have a 555, base is 10, 3200, base is 10. You can have a combination of 0 to 9. But here I can't consider this as 32, or I can't consider this as 00. That is why you need to consider it separately. Then its base is 10. This is what the example. Then how we are going to represent this decimal number? Here you can see the example. So here I have a 542.76. This is what? Decimal point. So that dot is what? Decimal point. Very, very important how we are going to represent it. Okay. First, let me write, as I told earlier, this positional number system, in that we have a decimal. Totally it is of 10 digits from 0 to 9, and it will express with the power of 10. Fine. Then how we are going to write? 5. What is the digit? First one, 5 into, then what is the total number of digits for a decimal? 10 plus, then I will take 4 into 10 plus, what is the next number? 2 into 10 plus, next number is 7 into 10 plus 6 into 10. Okay. So now we have to give a weightage for the each number. So let me start with a number which is left to the decimal point. What is that? 2. It starts with 0. So I will give the power 0. This is power 1. This is power 2. Okay. Then whatever the number we have after the decimal point should be the negative weightage. So that's why it will become 10 power minus 1. This is 10 power minus 2. Okay. After that, so how I am going to represent? 5 into 10 power 2. That is 10 into 10. How much? 100. Right? Plus 4 into 10 power 1. So 10 power 1 is 10 into 1. That is of 10 itself. Plus 2 into 10 power 0. You need to remember one thing. Any number with power 0 is always equal to 1. Very, very important. Any number with power 0 is always equal to 1. So here 2 into 10 power 0. If it is 10 power 0, then it will be 1, not 10. Plus 7 into 10 inverse 1. That is 10 to the power minus 1. How I am going to write? 1 by 10 plus 6 into 1 by 10 power 2 in the sense what? 100. So it will be 1 by 100. Okay. Then I am going to multiply. Again I will add this. After that you are going to get this number called 542.76, which is of a base 10. So here you can see we have a weights, digits and values. So that digits are what? 5, 4, 2, 7, 6. Then what is the weightage which I had given for the 2? That is 10 power 0, 10 power 1, 10 power 2 for the number which is right side to the decimal point, that is of negative weightage. So it will be 10 power minus 1 and 10 power minus 2. So if I found out this 10 power 2, that is 10 into 10, 100. That is 5 into 100 will be 500. Then 4 into 10 will be 40. And here 2 into any number, that is what, 10 to the power 0. The value is 1. So we are going to get 2 into 1 as 2 here. Then 10 power minus 1. So 7 into 1 by 10. It will going to give you 0.7, and 6 into 10, 1 by 100, then it will gives us 0.06. So if I add all these, then it will going to gives us 542.76. This is regarding decimal number system. We'll see the second type of number system. That's all regarding binary number system. So in this, digital computer represents all the kinds of data and information in the binary system. That is what? 0 and 1. So here we have a zeros and ones in order to represent the binary number system. It consists of 2 digits. If it is having a 2 digits, then what is its base or radix? That is 2 only. So it consists of 2 digits. One is 0 and we can call that as a low voltage. If it is 1, then that is of high voltage. If it is having only 2 numbers or 2 digits, then its base or radix will be 2, and each digit or a bit in a binary number system can be either 0 or 1. Then what is its power? How it will going to be expressed? The positional values are expressed in the power of 2. Here you can see the example 1011. Apart from 0 and 1, you can't see any number in the binary number system. I can't write like this 423 base 2. Why? Because this is not the number which is belongs to the binary. Fine. I have to deal with only 1 and 0. Then we can call that as a binary number system. So here if I am writing 101011 of base 2, then it can be considered as a binary number system. But this is not the binary. Why? Because here we have a number which is other than 0 and 1. That is why. So these are the things which you need to remember regarding this binary number system. So now we'll see its representation now. So here I have an example 11011 point. That is what we are calling it as a binary point. And I have 10 which is of base 2. Then how we are going to represent it? So first I have a number 1 into it's will going to be represented with a power of 2. So that's what I am writing 1 into 2 plus 1 into 2 plus 0 into 2 plus this 1 into 2 plus 1 into 2 plus 1 into 2 plus 0 into 2. Okay. How to give the weightage? The number which is left to the binary point, that is of positive weightage. The number which is right to the binary point, which is of negative weightage. So for this 2 number, this will be minus 1 and minus 2. And for this number, it starts with a 0. Weightage is 0. 2 power 0, 2 power 1, 2 power 2, 2 power 3 and 2 power 4. Okay, this is how we are going to represent. So here you can see that weights we have a 2 power 4, 2 power 3, 2, 1, 2 power 0, 2 power minus 1 and 2 power minus 2. And the digits are this 1, 1, 0, 1, 1, 1, 0. Okay, then what is 2 power 4? 2 into 2 into 2 into 2. 2 2s are 4, 4 2s are 8, 8 2s are 16. Then 2 power 3 is 8, 2 power 2 is 4 and 2 power 2 is 2. And then any number with power 0 is always 1. Fine. Then 2 power minus 1 is this 0.5 and 2 power minus 2 is 0.25. So if we are adding all these things, then we are able to get this number. After this, here you can see that in this binary number system, here we have a most significant bit, that is the leftmost bit 1 will be considered as a highest order bit, and we are calling this as a most significant bit, or in short it is MSB, which is having more weightage. So here you can see that 2 power 4 is greater than all these things. That is why we are calling this as a most significant bit. Which is having a least significance, then we are calling it as a least significant bit or a LSB. This will be the least significant bit. Okay, this is the most significant bit, this is the least significant bit, MSB and LSB. This is how we are going to represent the binary number system. We'll see the next one. That's all regarding octal number system. What do you mean by octal here? It's all related to 8. So in this, it has a starting with 0 to 7. Whether it is decimal or octal, we start with a 0. And by the 0 up to the 8 number, that is what 0 to 7, 0, 1, 2, 3, 4, 5, 6, 7. That's all of total 8 digits. Then we are calling it as what? Octal number system. If it is of total 8 digits, then its base or radix is always 8. And we are going to represent with a power of 8. Then what is the example you can have for this octal number system? 222 and base is 8. Here you need to concentrate on the number. I can't write 973 base 8. I can't take 9. Why? Because this 9 doesn't belongs to octal number system. The number should be lesser than 8, or it can be a combination of any number from 0 to 7. It can't be greater than 8, 7 or 9. Okay, and even I can't write like this 870 3, 4, 9 of base 8. Why? Because this 8 and 9 does not belongs to the octal number system. So for that we have an example. 450 base is 8 and we have a 700, our base or radix is 8. How we are going to represent it? Again with the same format, 2 3.56 here. So 2 into 8 plus 3 into 8 plus 4 into 8 plus 5 into 8 plus 6 into 8. And I have to give the weightage 8 power 0, 8 power 1, 8 power 2. Then here, which is right to the octal point, then we have to give the negative weightage 8 power minus 1, 8 power minus 2. Again, we are going to have a digit 2, 3, 4, 5, 6. And if you are finding the weightage, that is 8 power 2, 8 into 8, 64, 8 power 1, 8. Any number with power 0 is always 1. And here 8, that means 5 into 1 by 8. Then that is of 0.125. And we have a 6 into 1 by 8 power 2 is 64. So 6 into 1 by 4, then it will be represented in the terms of 0.015625. Okay, this is how we are going to represent the octal number system. We'll see the last slide. That's all regarding hexadecimal number system. So now we got to know regarding decimal, that is of 10 digits 0 to 9 and base is 10, and we have a octal. Octal is of 8 digits 0 to 7, base is 8, and we had a discussion regarding binary, that is of 2 digits 0 and 1, base is 2. Then what about this hexadecimal? In the name only we have hexa, in the sense what? 16. Here in the hexadecimal number system, totally it consists of 16 digits. Then how we are going to represent all these 16 digits? First 10 digit will be 0 to 9 and another 6 digit will be from A to F. Okay, very important. It has a total number which will be a combination from 0 to 9 and A to F. So here up to 0 to 9, no worries, that's all of decimal number. After the 9, what will be the value? That is what? A to F. So A to F represents the value from 10 to 15. So here you need to concentrate. A is 10, B represents 11, C represents 12, D represents 13, E represents 14, and this F represents 15. This is very important. So when it comes to the hexadecimal, 0 to 9 and 10 to 15, 10 is nothing but A, 11, B, 12, C, 13, D, 14, E, and 15 is F. That's why all we have to represent after the 10, after the 9, we have to represent it with the help of A to F. Then what is the base or radix of this number system? That's all regarding 16. Why? Because totally we have 16 digits. That's why its base or radix is 16, and it will going to be expressed with the power of 16. Example you can see here. A, 3. A is what? 10, and 3 is a number which is comes under 0 to 9 and its base is 16. 2 BC, 16 phase, 16 E, base or radix is what? 16. Then how we are going to represent it? Again like this, 5 AF dot D. That dot is what? Hexadecimal point here. How we are going to represent? 5 into 16 plus A into 16 plus F into 16 plus D into 16. The number which we have right to the hexadecimal point should be negative weightage. So it is of 16 minus 1, that is power 1, 16 power 0, 16 power 1 and 16 power 2. So 16 power 2 is what? 256. 16 power 1 is 16. 16 to the power 0. Any number with power 0 is always equal to 1. And we have a 16 power minus 1, that is of 0 into 0625. So how we are going to write then? 5 into 256 plus A. A is what? 10. So how we are supposed to write for that? Let me consider 5 into 16 plus then A. In the place of A, we have to consider 10. 10 into 16 power 1 plus in the place of F, we have to consider that as 15 into 16 power 0 plus D. What is the value for D? So D is 13. 13 into 16 power minus 1. Okay. So here what we are going to do? Power 0 minus 1, 1, and it is of 16. So 5 into 16 power 2 is 256 plus 10 into 16 power 1, it will be 160. Then 15 into 16 plus 3 into 16 minus 1 will be 13 into 16 minus 1 will be 0.0625. This is how we are going to represent this hexadecimal number system. This is how you are supposed to understand regarding the different types of positional number system. Let me summarize all these together. Totally we have 4 types. In that we have a binary, octal decimal and hexadecimal. So the base of binary is 2, and what are the symbol it will going to have? 0 and 1. When it comes to the octal, base or radix is 8. It consists of 0 to 7. 0, 1, 2, 3, 4, 5, 6, 7. Up to that we have in the octal decimal, that is of total 10 digits. That's why its base or radix is 10. It is of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we have a hexadecimal, that is totally of 16 digits. 0 to 9 will be common. After that we have A to F. A represent 10, B 11, C 12, D 13, E 14 and F is 15. This is how we are going to represent the number by making use of a digit. That is what we are calling it as a positional number system. Each number has its own weightage and position. I hope you all understood this session. In my coming session, we are going to see how we are going to convert from one number system to another number system with example problem. Let me meet you in the next session. Until that, keep learning, keep on growing. Thank you.